Here's my of all the timing. Sorry. So we have the angle A and the side opposite. So we'll use that, and what is this forcing us, or which angle is this forcing us to find first? Very good. So we just write it out. We have sine of A, so we have sine of 30 is to its side opposite, as the sine of C is to its side opposite. When we're solving for the angle, we have to just move the one denominator. You don't have to do any extra stuff after that. So we get 20 sine of 30 divided by 10 equals the sine of C. So in my calculator then, I press a bunch of buttons. We have fraction bar, 20 sine 30 over 10, and I get 1. And now I have to figure out what angle has a sine of 1. So I inverse sine of my angle, and lo and behold, what do we have? We have a right triangle. You get a right triangle. So you get, so there's your 90, which means this angle has to be 60. Now, if you recognize that, could you go ahead and do law of sines one more time to find that side length, or could you use the ratio of sides for 30, 60, 90? Yeah, or the fact now that you know it's a right triangle, could I use Pythagorean theorem to find that side length? Yeah, there's a bunch of different methods you can get at this point. And when you get, the other one, if you do it, no matter which way you go with it, you should get 10 root 3 for that. Okay. Yeah. Yeah, radical form is absolutely fine. Absolutely fine. If your calculator spits out a radical, leave it. It's fine by me. Okay? That's absolutely fine. I don't think anybody's calculator in here doesn't spit that out. Yeah, I think we're all doing that one. Okay? Does that make sense? I know if you did that one, you saw, wait a second, 90 degrees? What? It's okay. It happens. And that's the whole thing is we always say it's not drawn to scale, and a lot of times what we'll do is we'll just write out in words what the parts are, and we just do a quick draw of it, so it doesn't have to necessarily make it go that way. Right. So law of sines will work with 3069 as well.
Now, is there any way you can look at a problem like number 10 and say across from the 30 is 10, and since that 20 is double of the 10, that's going to be 3069? You make that assumption that a short leg and
you can kind of get away with that one. I'd rather, yeah, because once you do the one law sign, you'll get a 9. Oh,
right,
and then it goes real quick, you know. And or if you get two side lengths, I mean, you don't know if it's a right triangle, you know. That way you kind of bump into it.
right, all right.
Are the rest of the law signs in that one okay? They're not bad. Remember, always write down what you're about to do before you do it. That's kind of the big kick on a lot of these things. Okay. So back to the front page then. I know where most of you guys have already started to screw up. Remember yesterday we made that whole list of what parts you have to do for each section and all, and we were going through that. And in number 1 through 4 was all basically Pythagorean theorem. And when you're dealing with Pythagorean theorem, you know that it has to be Pythagorean theorem because they're all right triangles. So you know where your opposites are. So 1's easy. 2, on the other hand, you have 2 root 2 squared plus root 13 squared equals x squared. Right there is where most of you guys screw up. Whenever you have a number in front of the radical, you have to put it in parentheses before you square it. Because remember, guys, 2 root 2 squared is not the same thing as the quantity 2 root 2 squared. You have to put it in parentheses. Right? Guarantee if there's a problem like that on there tomorrow, 15% of you will screw that up. This is number 2. Whenever you have radicals with parentheses, or with radicals with numbers in front of the radical, you have to put it in parentheses to do it correctly in the calculator. You have to. If you don't, you're going to get it wrong. Okay? So you did. Yeah, and that's the thing. You got to do parentheses on it. You have to do do parentheses. Okay, that is the biggest mistake most students make. It's not the fact that you don't know how to use Pythagorean theorem. It's the fact that you forgot how to use a calculator. So 1, 2, and 3 are all finding the hypotenuse. 4, they changed up on you. You didn't have to find the hypotenuse, you had to find a leg. And you had to do a little bit of backwards math. So you had x squared plus 11 squared is 15 squared. So 15 squared. Subtract the 11 squared. And we get 104. Take the square root. Oops, wrong button. Square root of my answer, and it gives me simplified radical form. Perfect. That's exactly what you're writing, because look, the instructions says leave answers in simplest radical form. Calculators are your best friend. My Alpha 2 class doesn't get a calculator starting on Monday. It's going to be awesome for about the next 6 weeks. They're going to trig and their tier. Yeah, if we start full unit circling, favorite thing to teach. Favorite thing to teach. Because it makes sense of why everything works. Then we get into special right triangles. And remember, when we're working with special right triangles, you have two ratios. Or two sets of ratios, excuse me. Bless you. And get those two sets of ratios of sides for the special right triangles. And we talked about this yesterday. Whenever you're given specific information, it's a matter of remembering that the angle always is looking at a side opposite. So for example, in number 5, what angle do you know across from? The 90. And number 5, we know across from the 90 in our diagram, and it happens to be equal to 4. So when I write out my setup, I know that this part equals 4, which means I need to solve for x. 2 times something is 4. What's the something? 2. So you'd have to divide that by 2. So it means everywhere I see an x, what am I going to replace it with? 2. And I go on my merry way. That's all you have to do. Okay? We try to set it up in those ways so that way you don't have to overwork, overthink. Same thing with 6. In 6, again, you have a 30, 60, 90 triangle. So we have the same ratios of sides. But now in 6, across from what angle do you know? The 30. Across from the 30, and this so happens that that then equals 2 root 3 over 3. Which means everywhere I see an x, what am I going to replace it with? Yep. So this becomes 2 root 3 over 3 times root 3. This becomes 2 times 2 root 3 over 3. Not dividing anything, I'm not doing anything, just replacing values of x. So in the calculator, I just have to press buttons then. So I have fraction bar, 2 root 3 over 3 times root 3. And there's your answer. So across from the 60 is equal to 2. Toe? Sam, kind of weird to have a toe across from there. So that equals 2. And then here you're going to get 4 root 3. Remember, guys, calculator does the work for you. You don't have to worry about it. It does. You just have to set it up. One of the things that we did not really get a chance to talk about yesterday were the combo platters, if you will. you look at 9. 9 we have 60, 90, 45. We have to move that 7 root 3 out of the triangle of the 30, 60, 90 and into the triangle of the 45. Okay. So you have to basically use both ratios. So you have to figure out what side is shared between the two triangles. Where's the reflexive side, if you will? There. And that side is across from a 30. So what we need to do here is set up the ratio and go for it. So we have 30, 60, 90. And in that triangle, you know across from which one? 90. You know across from the 90. We got to get to the 30. And then I just have to divide it by 2. If I put that in my calculator, it'll spit that back out, 7 root 3 over 2. Okay? So now, everywhere I see an x in the 30, 60, 90, I replace it with 7 root 3 over 2. And I only have to worry about this portion, because now it's across from a 45, and I have to put it across from a 90. So if x is 7 root 3 over 2, that means across from the 90 will be 7 root 3 over 2 times root 2. And once again, your calculator will do that, so you can see it. You get 7 root 6 over 2. As long as you know your ratios of your sides, the rest of it's easy because the calculator does the work. Okay? You have to understand how the sides work and go from there. All right? I don't know if you've had a chance to try 10, but give 10 a shot. We'll see how we do. We'll check it here in a second. Let me write it up in case you haven't. Excuse me. You haven't had a chance to finish out number 10, give 10 a shot. It sets you up with 30, 60, 90, they're giving you across from which one? 30. That's the easiest one, isn't it? So you know across from 30 is some value of x. Well, in this case, that x is being replaced by a. So what's across from the 60? You have 5 root 3 right there. And then from there, that's now across from a 45. Which means across from the 90, all I have to do is multiply that by root 2, and you get 5 root 6. Walking through the ratios. Remember, you start with 30, 60, 90. It happens to be looking at, this one is 5, so this one would be 5 root 3. I take this value into the next triangle. I know it's equal to 5 root 3. So you get 5 root 3 times root 2, which is 5 root 6. It's just a matter of bouncing it through everything else. Now, I think that was pretty much all we had going on yesterday with those. So if we flip over to the second page, 12, Evan, 13. Grayson.
What's up?
You have your earphones out. 14. John. 15. John. 16. You've got 17. And last but not least, 8. Take a second. There's plenty of board space. Go. And we'll check it. The rest of you guys do it also. Make sure that you guys are doing it right.
Or it could also be a part of us.
Oh, yeah, yeah. Or somebody go, hey, those that don't have a marker, go with somebody that has a marker and help them. Yes. Solve the triangle.
Make sure you put the number in the problem.
Go stand by somebody that has a marker if you don't have a marker, and make yourself look cool, and make yourself be a helpful person in society, and do stuff. And actually, you can do this too. Come on. Here. We gotta work. If one of you guys want to use the smartboard, go ahead. So if we go to that last page there, you've got, I'm looking at number 6, 9, 14, and 7 root 5, and I want to tell what kind of a triangle it is. When you're given anything that has a radical to it, you have to figure out what the decimal equivalency is. Now, I know that if you type that in your calculator and you hit enter, it'll say 7 root 5. Press the double arrow after you do 7 root 5. What do you get? What was it? I'm sorry? So that means it's bigger than the other two, correct? So that means it's playing the role of the hypotenuse. So we write 17 root 5 in parentheses quantity squared. What's the relationship to that with 9 squared and 14 squared? And this is where making sure you have parentheses around your radical stuff becomes a super, super important thing when you're trying to deal with what type of triangle it is. So when I ask you guys to tell what type, to determine what kind of a triangle it is and show your work, this is the kind of work that you do. So you type in the calculator, 7 root 5 parentheses squared, I hit enter, I get 245. And I do 9 squared plus 14 squared, and lo and behold, I get 277. Is 245 larger, smaller, or equal to 277? Therefore, what kind of triangle? All right, that's what we're looking at, guys. Tomorrow, I will give you guys the law of sines. You don't have to memorize that. But the rest of it's all on you. Okay? I'll write out and have you guys that law of sines thing, because that's something we'll give you guys on the formula sheet for the final. Because it really only comes up once or twice throughout the school year. But then we'll do all the SOHCAHTOA. That's got to go. Pythagorean theorem, special right triangles ratios. There are tons of extra problems on here. Work. Got questions, swing by in the morning, and then we'll go from there. Any else? Absolutely. That's a strong test taking strategy. Yeah, finish out what you can, and then I think I'll try to collect this stuff tomorrow. We've done most of it, so it shouldn't be so bad. It should be a lot of. Obviously, if you didn't get a chance to finish out a couple of them here or there, you at least get the practice off of it. Those, and like even the ones at the very back, they're just extra problems. But we've done. About everything that I have. So. There's been a we'll have a little bit of trig here and there in when we get into the shapes and stuff like the areas and all, because I can give you like a parallelogram with a certain degree, and you can figure out the heights, but things like that. But so nothing like this. No, you can still use sine, cosine, tangent, and stuff like that. But it's not just straight solve triangle. Guys,